Hello, this is Dr. Hanaa Assil, and this is Unit 6 of January 2025 of the Pearson Edxcel International A-Level Chemistry. So let us look at the questions. This is the first question. The question is about experiments involving chromium ions or compounds containing chromium. A small amount of chromium-3 sulfate was dissolved in deionized water, forming a solution containing a complex ion. So they're dissolving chromium-3 salt in water. What would be the color of the solution? Of course, when we dissolve chromium-3 plus in water, it forms this complex ion, which is green in color. Remember, chromium-3 is a green complex, and the formula of this complex ion is chromium with 6 water ligands. Remember, each water does not have any charge, so the overall charge of the complex is the 3 plus of the chromium. Sodium hydroxide solution was added slowly to the complex ion solution until a solid Q formed. The solid was then separated by filtering under reduced pressure. So this chromium complex with 6 water, we added the sodium hydroxide dropwise. Of course, what happens is some of the water molecules are deprotonated. That means the water loses an H plus and becomes OH minus. So the formula of this new precipitate is chromium with 3 water and 3 hydroxide. Please notice that the chromium alone has a 3 plus charge. The hydroxides have 1 negative each. So that means the 3 plus is neutralized by the 3 negatives of the OH minus, and the complex does not have an overall charge. Draw a label diagram of the apparatus used to filter under reduced pressure. Please practice how to draw this diagram. This is a Buchner funnel that has a porous base, that means holes that we cover with a filter paper, and the conical flask is closed with a bung and connected to a pump. This is filtering under pressure. Give 2 advantages of filtering under reduced pressure compared to the gravity filtration, which is the normal filtration with a filter paper and a glass funnel. Of course, the filtering under reduced pressure is much better because it is faster, and the residue formed is drier because the pump sucks up much of the water that was in the residue. A sample of solid Q was added to manganese 4 oxide and excess sulfuric acid. A redox reaction occurred, forming a mixture containing dichromate ions. Describe what you would see. So we're starting with 2 solids and an acid. So the solid manganese dioxide, and the Q is a solid, and what we got was a dichromate ion, and you should remember that dichromate ion is orange in color. So when we do this reaction, what would be seen? The solid disappears and we get an orange solution that is formed. Excess sodium hydroxide solution was added to a second sample of solid Q, forming a green solution. Give the formula of the complex ion that forms the green color. Well, solid Q, this is what we said solid Q was. That is the complex between chromium and 3 water ligands and 3 hydroxide ligands. Now we're adding excess sodium hydroxide. Remember, when we added drops of sodium hydroxide, we said we're going to deprotonate some of the water. So 3 of the water molecules were deprotonated. Now, when we add excess of the sodium hydroxide, we get a green solution because we deprotonated more of the water. So now we have chromium with 6 hydroxide ions. Again, each hydroxide has 1 negative and the chromium is 3 plus. That means we have 3 positives and 6 negatives. So the overall charge of that complex is 3 minus. Again, what is the type of reaction that is taking place? We said the sodium hydroxide here is acting as a base. This is deprotonation. Question 2 says, this question is about synthetic dyes. The compound 4-chlorophenol is used in the synthesis of a dye called solvent orange 86. So we're trying to make that compound at the bottom right, starting from phenol. A student suggested using iron as a catalyst in step 1. So which one was step 1? This is the one where we are trying to put chlorine on the benzene ring of the phenol. Explain why it is not needed in the reaction with phenol. So we don't need a catalyst when we are reacting with phenol, even though chlorination of all other aryl compounds such as benzene requires this catalyst. Remember that to put a chlorine on a benzene ring, we needed a catalyst, so anhydrous aluminum chloride catalyst, in order for the reaction to occur. But with phenol, we do not need a catalyst, and that is because the lone pair of electrons on oxygen overlap with the delocalized pi cloud of the benzene ring, which increases the electron density of the ring, making it more susceptible to electrophilic attack, and that is why phenol is more reactive than benzene. The student suggested using the apparatus shown to carry out the heating under reflux in step 2, but there are 2 mistakes with this setup. Identify the 2 mistakes. In each case, describe the problem that would occur due to this error. You should assume the apparatus supported using appropriate clamps. So what's the problem with this setup? First of all, that part on top of the condenser, that should be open. It shouldn't be closed like this. So the top of the condenser is closed. That's a problem because in this case, the pressure will build up and this may lead to explosion. The other problem, the direction of the water. The cold water should go into the condenser from the bottom and go out from the top, and this is important for more efficient cooling. Diazonium ions can react to form azodyes. The ions are formed as shown. The diazonium ions then react with phenol in alkaline solution to form 2 test tubes containing the reactants are left to stand in ice water baths for 5 minutes as shown. So we have the phenylamine, HCl, sodium nitrite in ice bath. The other one has phenol in sodium hydroxide, and then the contents of test tube B are carefully poured into test tube A to give the azo dye. Then the next part of the question says the impure azo dye is separated by filtering. Under reduced pressure, the impure azo dye is recrystallized using ethanol as solvent. The purified sample of the azo dye is dried. And the first question is, give the systematic name of HNO2. What is HNO2? This is called nitrous acid. Remember, HNO3 is nitric. HNO2 is nitrous acid. State why the HNO2 is formed when required in test tube A rather than bought from a chemical supplier. Remember, when we need nitrous acid, we don't buy it in a bottle. We make it inside the reaction mixture, and that is because nitrous acid decomposes easily. Explain why the test tubes in step 1 are left in ice water bath for 5 minutes before we add them together to make the azo dye. Remember that this reaction has to happen at a temperature below 10 degrees Celsius, so we keep the solutions in ice water for 5 minutes to make sure the solutions acquire a temperature below 10 degrees in order to avoid decomposition of the diazonium salt. Remember, diazonium salt decomposes at temperatures higher than 10 degrees. Explain why a student carrying out step 4 was told to ensure they use the minimum amount of hot ethanol to dissolve the azo dye. Which one was step 4? This is the one where the impure azo dye was being recrystallized. And remember, what do we mean by recrystallization? You should know how to explain this. When we're doing recrystallization of a solid, first we should dissolve it in the minimum amount of hot solvent, and that is in order to allow as much crystals as possible to form on cooling, because if I add too much solvent at the beginning, then when I leave it to cool, some of the solid will remain in the solution. So the first thing we do is dissolve in a very small amount of hot solvent, filter while hot in order to remove insoluble impurities, and then allow it to cool to form crystals. In this case, the soluble impurities will dissolve whether the ethanol is hot or cold, but the azo dye dissolves more in hot ethanol. So we need to put a little bit of hot ethanol so that as soon as we leave it to cool, then it forms crystals, and then we filter the crystals. State how the purified azo dye could be dried in step 5. Well, how do we dry a solid? Usually it is much better to dry it between filter papers. Remember, you can say in an oven, but the oven has to be at a very low temperature, and it's always not a good idea to say dry in an oven because most crystals will decompose or break down when put in an oven. The hazard symbols present on the reagent bottle containing phenylamine are shown. State 3 precautions other than wearing safety glasses and a laboratory coat chemists should take when using phenylamine. In each case, give a reason for your answer. So let's see, what do these hazard labels mean and what precaution should we take? So that first one says that the phenylamine is corrosive, so we need to wear gloves because it is corrosive. So this protects the skin from being harmed by the corrosive liquid. Now, what else do we have that is a hazard? Well, it is toxic or it is a hazard to health. In both cases, you should use the reagent or the phenylamine in this case in a fume cupboard. So when we're working with something that's toxic or health hazard, so I shouldn't breathe it in, then do the experiments in a fume cupboard. What about that last hazard symbol on the right? You should know that that means it is an environmental hazard, and that means disposing of the waste should be in sealed containers or in specific containers, or we can say do not pour the waste down the sink or in the regular sewage treatment. Compound X is a colorless, viscous liquid used in the manufacture of fragrances and resins. Molecules of X contain elements carbon, hydrogen, and oxygen only and have one functional group. Qualitative tests on X show that first, it burns in air with a very smoky flame. Now, when we say that something burns in air with a smoky flame, that means it contains a benzene ring, because the presence of the benzene ring causes it to form carbon as a solid in addition to carbon monoxide, carbon dioxide, and water when it burns. So it forms a very smoky flame. Then we're told that X forms an orange precipitate with 2,4-dinitrophenylhydrazine. Now, which compound forms an orange precipitate with 2,4-dinitrophenylhydrazine? Remember that that means it is aldehyde or ketone. It does not form a red precipitate with Fehling solution. So if it does not react with Fehling solution, that means it is not an aldehyde, it is a ketone. Forms a yellow precipitate with alkaline iodine. What forms a yellow precipitate with alkaline iodine? Remember, that means it has a methyl next to a carbonyl group. So this is a group that is present on the benzene ring. Complete combustion of 4.7 grams of X produced 13.8 grams of carbon dioxide, 2.82 grams of water. Determine the empirical formula of X. Again, when we're given this kind of question, we get number of moles of carbon dioxide, mass over molecular mass. Each mole of carbon dioxide has one carbon, so the number of moles of carbon is the same as the number of moles of carbon dioxide, and that means I can get the mass of carbon that is present in X. The mass would be the number of moles times the mass number of carbon, which is 12, so that means I have this mass of carbon. We do the same to water. Number of moles of water is mass over molecular mass of water, but then each mole of water has two hydrogens. So the number of moles of hydrogen would be the number of moles of water times 2. And that means I can get the mass of hydrogen. So the mass of hydrogen would be times its mass number. And the mass of oxygen would be the rest of the 4.7. So if I have mass of carbon, mass of hydrogen, subtract them from the original 4.7 of X, that would give me the mass of oxygen. Now we're required to get the empirical formula, so we put the masses, divide by the mass number, divide by the smallest. This gives a ratio of 8 to 8 to 1, and that means the empirical formula is C8H8O. The molecular formula of X is the same as its empirical formula. Now use this information and your answers to the first parts to deduce the structure of X. What do we know about X so far? We found that its formula is C8H8O, and we're told that is the molecular formula. We found that it contains benzene ring because it burns with a very smoky flame. It has a methyl ketone group. It has a total of 8 carbons, so that means the benzene ring alone is 6, so that means I have 2 more, and that contains a carbonyl with a methyl group. Question 4 says, phenolphthalein is an indicator used in acid-base titrations. It can be represented by the simplified formula H2 with the indicator. When mixed with an excess of hydroxide ions, it reacts rapidly, forming a pink solution due to the ion of the indicator 2-. Remember that phenolphthalein is pink in a base. The pink color then fades to colorless when it forms this kind of species. A student carried out an experiment to find the order of this reaction with respect to the indicator. A solution of phenolphthalein was mixed with a large excess of potassium hydroxide. The resulting solution contains this ion of concentration this. The concentration of the ion was measured over a time period of 300 seconds. First, give the name of the most suitable technique to monitor the concentration of the indicator during the reaction. What can we use to monitor the concentration? Well, what do we have? We have something that is pink and it is slowly changing to colorless. When we're trying to track a change in color, we can use colorimetry. Colorimetry is a method of following the rate of the reaction if there is a change in the color of the mixture. Plot a graph of concentration against time. We're given the table. Of course, you label the X and Y axis, the time in seconds, don't forget the units. On the x-axis, concentration in moles per decimeter cubed on the y-axis. Distribute the numbers so that you use as much of the graph paper as possible. Plot the points with an X, and this is the kind of graph that you get. Determine two successive half-lives for the concentration of the indicator. Well, how do we get the half-life? We're starting with a concentration of 5. Remember, half-life is the time taken for the concentration to become half of it. So 5 to become 2.5. The 2.5 to become 1.25. And we find that the first half-life takes 70 seconds. And again, from 2.5 to 1.25, that is again a difference of 70 seconds. That means that the half-life is constant. So when we're asked to deduce the order, this is first order. Remember, when the half-life is constant, this is first order. Explain why the results of this experiment do not allow the overall order of the reaction to be determined. Well, in order to get the overall order of the reaction, I have to take into consideration all the reactants. Now, what we have been doing is just tracking the concentration of the indicator, but we did not determine the change in rate with respect to concentration of hydroxide ions. So the results do not show the order with respect to hydroxide ions. So I need to repeat the experiment where we keep the concentration of the indicator constant and change the concentrations of the hydroxide in order to determine the effect on the rate. Another student carried out an experiment to find the activation energy of the reaction between the indicator and the hydroxide ions. A graph of len of the rate, natural log of rate, against 1 over temperature was plotted, and this is the graph. Calculate the activation energy for the reaction using the gradient of the graph and the Arrhenius equation shown. Give your answer to an appropriate number of significant figures. Remember, in the Arrhenius equation, if we plot natural log of K, which is the rate, versus 1 over T, then the slope will be equal to the minus EA over R. So if we get the slope of this line, it is equal to minus EA over R. Where is the slope? Well, let's decide the slope. The slope is y2 minus y1 over x2 minus x1. Now remember that this is a negative slope, so it is the one down minus the one up. So minus 5.5 minus of the minus 4.4. So actually it is minus 5.5 plus 4.4 over the difference in the x-axis. This gives this kind of slope, and it is a negative slope, of course. Now, this is equal to minus EA over R. That means that EA is equal to minus the slope times R. We multiply that and we get the EA, the activation energy, in joules. You can divide that by 1,000. So this is 57.1 kilojoules. Then the question says a value for len of collision factor. So len, natural log of collision factor, that's the constant that is at the end of the Arrhenius equation, is of minus 4.4 given to two significant figures, was suggested by the student. So the student suggested that that constant at the end of the equation, where we have natural log of k is equal to minus EA over R times 1 over T. So we are plotting len k versus 1 over T. We said the slope is minus EA over R plus a constant. Now, how do we get that constant? The student suggested it's minus 4.4, which is the upper intercept of that line with the y-axis. But is that correct? Remember that constant in that equation you get from, if I have len k and you want that constant, then that would be the intercept of the y-axis when the x is 0. So when x is 0, the intercept on the y-axis, that is my constant at the end of that equation, which is natural log of the collision factor. So actually, the natural log of k is equal to the natural log of collision factor when the 1 over t is 0. So that is the intercept in the y-axis when the x-axis is 0. So the student's suggestion is wrong. It is actually somewhere nearer to minus 4.0. And that's the end of the paper. Thank you for listening, and I hope that was useful. Good luck in all your exams.